problem number 1 from the free response portion basically asks us to, we're just going to do the top 2 histograms for sepal length. And so the top distribution, we are going to compare shape, center, and spread. So the top distribution has a higher center, which in this case we'll probably just say the median, and bigger range than the middle distribution. So that takes care of the size and the spread and the. So all we need left is a shape, the top distribution, is skewed left because of an outlier. The middle distribution is approximately symmetric. For part B, it says if we wanted to compare these two, since one distribution is skewed, we use the median and IQR. Problem number 2, we have a normal distribution for both parts. This normal distribution has a mean of 17,000 and has a standard deviation of 3,000. And we have saved 16,000. So what proportion of the motorcycles can we get? So we're going to do a normal CDF from a negative big number to 16,000 with a mean of 17,000 and a standard deviation of 3,000. And when I put that in, we get the answer of 0.369. Now for the second part, we have the same mean of 17,000 and the same standard deviation of 3,000, and this time we're given a percentage, and since this is the 40th percentile, that's 0.40. So this time we're going to do inverse norm so that we can get a score of 0.4 with 17,000 and 3,000 is the standard deviation. And that gives me a total of $16,239. And actually, if I was rounding it properly, then we'll call it 96 cents. Alright, so in number 3, we're going to find out the probability that we win the debate. So we have 15% of the sophomores, and they win 25% of the time. So the chances that a sophomore wins is going to be 0.0375. The chances that a junior wins, well, there's 40% of them are juniors, and they win 60% of the time, which is 0.24. And for the seniors are 45%. And they win 85% of the time. which is 0.3825 for the seniors. So this was sophomore, junior, and senior. And I'm going to add those numbers together. And so the probability that they win is 66% of the time. For part B, we're trying to figure out that if they lost the debate, what is the chances that a sophomore is chosen? Well, we know if 66% of the time they win, that 34% of the time they lose. And when you pick a sophomore and they lose, that happens 0.15 times 0.75% of the time, which is 11.25. So we take 11.25, which is sophomores and losing, divided by the percentage of losing, and that gives us 0.33. So 33% of the time that they lose, a sophomore got picked. For problem number 4, we're trying to find the mean and the standard deviation for this computer chip. So we have 140 times 4% because the mean is n times p. So 140 times 0.04 is 5.6. And then the standard deviation is the square root of 140 times 0.04 times 1 minus 0.04. So 140 times 0.04 times 1 minus 0.04, all underneath the square root, is 2.32. Find the probability that 5 or fewer. So the probability that x is less than or equal to 5. Because this is binomial, you want to do the binomial CDF with 140, 0.04, 5. So the chances of getting a distribution that is less than or equal to what we're talking about is 0.5097 or 0.51. And that's the chances that you'll get 5 or fewer chips. Alright, for number 5, we're going to do a test and then we're going to do the confidence interval. So P is equal to the proportion who use their phone for banking. And my initial hypothesis is P equals 0.38. My alternate hypothesis is P does not equal 0.38 because we're just checking to see if it's different. SRS and they called it a survey. They should have said a random survey, so we'll just write down it's a survey. For independence, they called 120 people times 10 is 1,200, which is less than the total number of people with cell phones. And for normality, 120 times 0.38 and 120 times 1 minus 0.38, which were 45.6 and 74.4, which are both bigger than 10. So that's the check. So we had 30 out of 120 users, which means that was 0.25. So here's 0.38. Here's the standard deviation, which is the square root of 0.38 times 1 minus 0.38 over 120. which is .04. Here's 0.25, which is p hat. And this is mu of p hat in the middle. So 0.25 minus 0.38 divided by 0.04 is my z-score, which is negative 3.25. Probability that z is less than negative 3.25. And of course we have to shade the other side too, because this is a two-way hypothesis test. So I'm going to use normal CDF again. And when I multiply it by 2, we get 0.001, which is less than 0.05. So I reject the null hypothesis. I have evidence to suggest that 0.38 is not the true proportion of cell phone users who bank with their phone. Not that that's much better. For part B, we don't have to worry about defining P because we already did. And so we got 0.25, and then the standard deviation is 0.25 times 1 minus 0.25 divided by n, which was 120. And so when we do the 90%, that means that there's 5% on each side. So I'm going to do inverse norm of 0.05 with a mean of 0 and a standard deviation of 1, because that's what a z-score is, z-score. So when I do inverse norm of 0.05 with a mean of 0 and a standard deviation of 1, it tells me 1.644. So when I actually plug this in the calculator, I will get the results of 0.185 on the low end, and when I change the minus to a plus, it gives me 0.315 on the high end, which means I am 90% confident that between 18.5 and 31.5% of cell phone users bank on cell phones. And that's it for the free response portion.